So for our example, this is the compound that we start with, and this is the product that we want to get. So the first step would be either using ozone lysis or hot KMNOH4, and I'm gonna do for this example, we're gonna use O3 and DMS. And that will give us, so that will cleave the chain right there and give us two aldehydes, which are actually the same exact, here, I'll draw a little better. It gives us two aldehydes, which are actually the exact same, they're the exact same, the two products. So we can actually just write it like this, since it's just 2 moles of that. And then you take, after you take the ozone lysis of that, you react it with a reducing agent like we had previously talked about. And for this example, I'm just going to do H2 and platinum, because that will take this C double bond O right here and reduce it into an OH. And then once you reduce it into an OH, you have your product. And that's a pretty simple example, but that's really how it's done, to use the synthesis of alcohols by reducing the amount of carbons in the chain. So now we're going to look at how to generate more carbons in the synthesis of alcohols. So first, let's just jump straight into like a little example here to show you what's going on. So we have a C double bond O connected to a methyl group, and we're going to treat it with CH3 and lithium, and this will actually cause that to have a negative charge and the lithium to have a positive charge. And then that negative charged CH3 will react here on the back side and kick this double bond up. And as you can see right here, it gives it a negative charge. So that causes the O to have, or the oxygen to have a negative charge, and then the CH3 attaches right here as another group. And then you quench this reaction and you get an OH. And so you go from having a primary alcohol right here to a secondary alcohol right here. And only having 2 carbons in this chain, you now have 3 carbons in this chain. So in order to do this, you use something called organometallic reagents. And this right here in this example is actually, that's a terrible arrow. That is actually an organometallic reagent that we use up here in the example. So there are 3 main types of organometallic reagents. First, we have lithium with an R group, magnesium with a halogen with an R group, and then you have an R group, triple bonded C to a sodium. So for this top organometallic reagent, we look at how to construct it, or how to make this actual reagent itself. So you take a R group with a halogen and you react it with lithium and ether, and that creates a R group attached to a lithium group. For the second one, you have an R group with a halogen again. You react it with magnesium and ether, and that produces an R group with a magnesium, and the halogen actually stays this time, so it's this halogen stays onto the chain, unlike up here where it is expelled and it's replaced within the lithium. And then for the third organometallic reagent, we have an R, so we start off with an R bonded to a C, triple bond CH, so it's a terminal alkyne. And then you react it with NaNH2, and that expels this hydrogen and replaces it with a Na, or with a sodium. And then so you have R, C, triple bond C with sodium there at the end. And so next, let's look at some examples of these three different organometallic reagents and how they react with compounds to generate more carbons into a chain. So let's look at some examples of how to synthesize alcohols using organometallic reagents. First, we have this as our starting material, and we're reacting with the CH3, CH2, lithium, and quenching it with H3O+. So, like in the previous little clip, you see that that's a negative charge that gets a positive charge, and that charge will go and attack right there. So then this double bond is kicked up, and this H3O plus comes in, and that, since it has a negative charge on the oxygen, it donates a hydrogen and creates an OH. So you get a product that looks like this. You still have your benzene ring, and then you get the OH right there, and then since you added a CH2, CH3, there's a CH2, there's a CH3, so those are carbons that you added, and that is the product you get from that example. Moving on to the next one, you see that you have a cyclohexane with a with a propene group, because it has a C double bond C right here. So first, if you look at the product that they want you to get, you see that it actually has less carbons than the starting material, so that doesn't really make sense. But in terms of adding carbons, but if you think about it, the first thing you have to do is you have to break this double bond, and to do that, you're going to want to react it with to break this double bond and add a double bond O. You're going to want to react it with O3 and DMS. And so that'll break the bond, it'll cleave the bond right there, and add on an aldehyde. So then that's the product you get from this reaction. And then, so you can see from here to here, there's one more carbon on the chain than there was for the previous one. And it went from a double bond O to a OH. So that makes you think, well, I have to use a reducing agent. Not a reducing agent, my bad. A organometallic reagent. So for this one, you can use, I'm just going to use CH3 and lithium and have a quenching reagent of H3O+. So once again, like up here, that lithium is going to have a negative, this CH3 is going to have a negative charge. It's going to attack the bottom of the double bond O right here, and that's going to kick that up. The quenching agent's going to donate a hydrogen, so you'll end up with this product, which is what we were wanting to do. So you see that you add one CH3, so it'll add right there, and then the hydrogen is going to add right there, and I make it an OH, and that's your product. So on to the last example. This one is kind of tricky. So they actually give you a phenyl group attached to a bromine at first. And so the first thing you have to do is synthesize an organometallic reagent. So what we're going to do is react it with Mg and ether, so magnesium and ether, and it's going to give you that phenyl group still attached to magnesium, and that bromine is going to stay. And then so you look at what you have up here, and you got to think about what you need. So what we have right now is we have a phenyl group attached to a magnesium and a bromine, and so we need this whole portion of it down here, and essentially that's what we're looking for. So you're going to react it with a reagent that'll give you all the stuff you're looking for up here. That'll set you up for doing the that will set you up for doing the reduction of or that will set you up for doing this last step of changing the C double bond O into an OH. So for this, we're going to use I don't know if you can see that, but we can use cyclohexane with an ethyl group off of it, and on the ethyl group we have a C double bond O on the first carbon. So this phenyl group will have a negative charge, like up here. This will get a positive charge, that's supposed to be a negative, and it will attack right here at this C double bond O. It'll attack right there, and so you have what you reacted it with still, and then you also add on this phenyl group, and that double bond O will turn into an OH, so then you have your product. I just drew it again down here to kind of show you how it reacts, but then so you get your product from reacting it with this compound right here, and that's just another way to do these examples, to do these problems. So that's all the material I have for chapter 10 over alcohols and their structures and how to synthesize alcohols.